Hello everyone, welcome back to your channel Physics with Oliver. Today we will discuss another problem from NEET 2022. If you have not subscribed the channel yet, then please subscribe the channel and press the bell icon. Now read the problem. The ratio of the distances travelled by freely falling body in the first, second, third and fourth second. A body is falling freely. We have to calculate the ratio of the distances travelled by the freely falling body in first, second, third and fourth second. Suppose the body is falling from here. This is the ground. This body is falling freely and the acceleration due to gravity is 10 meter per second square. After the first second, here the time t equals to 0 and here the time t equals to 1 second. The body is here. So this is the distance covered in the first second. And when the t equals to 2 second, then this is the distance covered in the second second. Okay. In this manner, we have to calculate the distance traveled in the first second, second second, third second and fourth second. Then we will calculate the ratio. Okay. We all know this formula that V is equals to U plus Ft and S is equals to Ut plus half Ft square. Right. So for the first second, the time starts from t equals to 0 and time ends at 1 second. Okay, so the time span is 1 second. So we can write that V is equals to, we all know for freely falling body, the initial velocity is equals to 0. So U equals to 0. So we can write U plus F means here G, that is 10 meter per second square. The body is falling in downward direction and acceleration is always in downward direction. So this sign will be positive. So we can write 10 T is 1 here. So 10 meter per second is the final velocity. And the S is equals to Ut, that is 0 into T plus half F is 10. T square is equals to 1 square. So this will be 5. This will be 5 meter. So after first second, the velocity, here the velocity was 0 and here the velocity is 10 meter per second and in the first second the distance covered is 5 meter. So we can write for the first second the distance covered is 5 meter. Okay, now we will calculate for the second second. For the second second, this value will change. We will just deleting this. This value will change. For the second second, the time start from 1 second and end at 2 seconds. So the time span is also here 1 second. Here U is 10 meter per second. Right? And the time span is 1. Here U is 10 meter per second and time span is 1. So here we will get V as 10 plus 10, 20 meter per second. And this is 10 into T. Here the answer will be 10 into 1 plus 5. So this will be 15 meter. So the distance covered is 15 meter for the second second. Right? And here after second second the velocity will become 15 meter. Sorry, the velocity will become 20 meter per second. Right? Now for the third second we will calculate the same thing for the third second and the fourth second. So for the third second V is equals to, here the initial velocity is 20, U plus F, T is equals to 1. So this will be 30 meter per second and S will be U T plus half F T square, that is 1 square. So this will be 20 plus 5. This is 25 meter. So for the third second the value will be 25 meter. And for the fourth second these values will be changed. For the fourth second, the initial velocity will be 30 and the result will be 40. I am erasing this and again writing this. The result will be 40, and here the initial velocity is 30. So here we will write 30 plus 5. This will be 35. Right? So the distance traveled in the fourth second is 35 meter. Okay, now we have to calculate the ratio. So 5 is to 15 is to 25 is to 35. So here we can write 1 is to 3 is to 5 is to 7. This should be the ratio. Okay, I hope you can understand this problem. If you have any doubt, you can ask in the comment section. Please like, share and subscribe the channel. Keep watching.